Welcome to Los Angeles Data Platform User Group. A good time of the day, everyone. Whenever you are, this is Los Angeles Data Platform. By the way, please drop your city and country into the chat so we know which communities we are serving. Thank you for joining us today. My name is Steve, and I'll be a moderator of this virtual meeting. I'll be joined by a few members of the team. One of them is Brody. The other one, hopefully, is going to join as well, is Yelena. And Yelena is going to take care of the t-shirt raffle. If this is your first time, or if you been with us before, you know how you can check us on Eventbrite, see all the previous meetings, all the upcoming meetings, as well as you can also see us on Meetup as well. There's also an email that you can send us directly asking anything that you think could be helpful. And of course, if you're following or if you're on social media, here's all the links that you can find us. Being at Facebook, Twitter, LinkedIn, and also we will be publishing this video recording on YouTube and Rumble. So you can visit those resources as well and find us there. We have an upcoming event. This is organized by the same group, actually an extended group that runs Data-Driven Technologies nonprofit. The event is called Data SQL Summer in LA, or as it used to be, SQL Summer in LA. It's going to be on June 10th. Loyola Marymount University. There are two links. You can go to sqlsummer.com/LA, or you can go to Linktree's SQL SAT LA. That will show you more information. The event is free to attend. It's going to be full day, and it's going to have at least 3 tracks of 5 to 6 sessions each. The only cost is if you don't bring lunch with you and you need lunch, you just pay for lunch. Otherwise, the whole event is entirely free, being paid by sponsors of the event. If you follow us on social media, but you want also to join our mailing list, you'll get all the event notifications, as well as a weekly newsletter that we're sharing on Friday. So you can scan the QR code or click on the landing.mailer.light URL and subscribe to our mailing list. And this event is sponsored by Data-Driven Technologies. It's a non-profit. That's the organization behind the user group. Also, the organization behind the mega event that I mentioned, SQL Summer in Los Angeles. And at the end of this meeting, we'll be raffling a custom t-shirt. You can scan the QR code, you can click on URL, enter your information, and at the end of this meeting, Yelena is going to raffle 1 t-shirt. There are a couple of caveats. You need to stay. The color might be not the same color, and we can only ship to US. During this presentation, please feel free to drop questions, although if I remember correctly, Jean wants all the questions to be at the end. So you can still drop them, but I'm going to voice them out at the end of the meeting. And without further ado, let's move to the rock star of today's online meeting. Jean, please take it away and introduce yourself.
Thank you so much. Let me share my screen. Great. Let me know if you're able to see my screen.
Not yet. Okay, perfect.
Are you able to see my picture?
Yep, your picture and advanced SQL for data scientist.
Yep, perfect. Great, let me hide this for the recording part. Great. One more time, welcome everyone. For those who don't know me, my name is Jean-Joseph. I'm a data engineer and administrator, work for Microsoft as a technical trainer. I am a former Microsoft MVP. I'm also the founder and the main organizer of Cloud Data Driven community. Under Cloud Data Driven, we have under Data Driven community, we have Cloud Data Driven and we have Feature Data Driven. Actually, Feature Data Driven is already scheduled for this September. If you have registered, I would highly suggest you to go to datadriven community.com and save your spot. My user group meet weekly. We meet every Thursday at 12 p.m. EST. Um, yeah, if you want to connect with me, feel free to do that. You can scan this and then connect with me. If you have any questions, you would like to reach out to me, you can email me at jean-joseph at microsoft.com. Great. For this presentation, um, it's all about advanced SQL for data scientists. So this is our agenda. I will do a brief introduction into SQL, and I will go over the data cleaning and prep using SQL. I will make sure that I share all the functions related to that. I may not be able to cover everything, but I have a couple I think you might need to know, or if you are using this session will be just like a recap for you. I will also cover the 5 major things to know in RDBMS, and then do some exercise on advanced SQL filtering, and then the key takeaway. At the end, there will be Q&A. I would highly suggest if you have a question, drop it in the chat and I'll be happy to address them at the end of the presentation. Um, uh, for example, let me make sure um, I have this. Give me 1 second. Perfect. I have this. For example, we cannot talk me about data analysis without thinking of data cleansing and prep. For you to be able to derive insight from the data has to be clean, right? And doing the cleaning, you have to think of prep your data. Prepping requires tons of things. It requires you, for example, to understand first the data classifications before you even be able to find out how would you be able to clean that data. It's also prepare you to get to know, for example, where that data is located and how can you centralize it. While data cleaning and preparations are often used interchangeably, I would say there is a difference between the two. Data cleaning involves in identifying and correcting or even removing errors, inconsistencies, inaccurate data, correct? And it also include tasks such as dealing with missing or duplicate value, handling outliers, correcting data like, for example, entry errors, and dealing with inconsistent formatting of value. When it comes to data preparations, on the other hand, it's involved in transforming and manipulating the data so that it is ready for analysis. And this include tasks such as scaling and normalizing that data, like featuring, engineering, and splitting the data into training and testing set, correct? In essence, we data Cleaning is about ensuring that the data is accurate and reliable, while the data preparations is about making sure, I would say, the data is in the right format and structured for analysis. And you need to consider both of them are very critical steps in the data analysis process and are necessary to ensure that the analysis is accurate and meaningful. Oops, sorry about that. There will be normally multiple steps, right? Consider as a data analyst or scientist, one of the most important steps in the data analysis is uh, process is cleaning and preparing the data, as I just mentioned. Here are some steps you can take to clean and prep your data. First, you have to understand your data. The first step in cleaning and preparing your data is to gain deep understanding of the data you are working with. This includes understanding the data source, classifications, and any potential issue with the data. The second step is to identify, for example, as you can see here, is to identify and handle what we call missing data, like missing data that can uh, come. Missing data can be a common issue in dataset. You can handle missing data by inputting value, removing missing value, or using machine learning algorithms to predict missing data value. And the third thing is removing duplicates, right? And then that help ensure your analysis is accurate. Deal with outliers, like outliers can also have a big impact on your analysis. You can handle outliers by removing them, transforming them, or treating them as a special case. And then we also need to standardize and normalize our data. What I mean by that, standardizing and normalizing your data can help ensure that your analysis is consistent and accurate. This involves in scaling your data to a common range or distributions. And for feature engineering, like what can we think of? For example, it's involved in creating new feature from existing data to better represent the problem you are trying to solve. This can include transforming variables, right? Creating dummy variables or combining variables together. And the last one is validate and test. Validate and test, for example, before using your data for analysis, it is important to validate and uh, test it to ensure that it is accurate and consistent. Overall, we can conclude that data cleaning and preparations is a crucial step in the data analysis process, right? And by taking the time properly clean and prepare your data, you can ensure that your analysis is accurate and meaningful, and therefore you can derive great insight or make great decisions out of your data. When it comes to SQL, we know SQL is very famous. And if you are a data scientist, you might be familiar more you- with Python, Scala, and some other framework. But if the data is already reside into any RDBMS system like SQL Server, Azure Synapse Analytics uh, using dedicated SQL pool, correct? Or any other DBMS like Azure MySQL or Postgres. Leverage SQL would be great because SQL is the engine of any RDBMS when it comes to accessing, modifying that data. So therefore, you need to understand the capability of SQL. SQL stands for structured, like query structured language. What can you do with it? It allows you to create objects, modify them. It allows you to control them and manipulate your data, correct? Okay, when SQL break into different languages, I would say definitions. The first one is what we call create, job, truncate, alter, comment, and rename. That's the first one. And the first one, those statements fall under what we call DDL. DDL stands for data definition language. They allow you to create objects. They allow you to drop objects. The second one is what we call DQL, and this stands for data query language. It allows you to read data from your RDBMS system. It doesn't matter if it's OLTP or OLAP. For you to read that data, you have to be able to know DQL. When it comes to modifications, you have to think of DML. DML stands for data manipulation language, and it allows you to insert data, update them, and delete them. The fourth one is what we call the data control language, right? It allows you to give access to people you think that are needed, and it allows you to revoke the access to people or team or users or application you think that should not have access, right? The fifth one is a transaction control language. It allows you to bypass the default behavior of SQL Server. By default, SQL Server is committed. You might be doing some transactions and you want to take control over that. Therefore, you have to know, okay, when to leverage commit when you begin the transactions, and you have to know when to leverage holdback in case if there is any unexpected unexpectation occur, should we roll back? And there is a save point, right? You consider inside of your transaction, you can leverage save point like a tracking, right? There's set operation like set isolation, transaction isolation, right? To read uncommitted data. You like if you take a look, but I do understand there are five different languages. M- Consider you or me as a data scientist. What should we focus on? You need to understand before we think we can focus, we're gonna break this down. We're gonna combine DQL and DML together. So therefore, you probably heard of that thing that called code, which is create, read, update, and delete. That create, which is the first C, has nothing to do with this create. This C is the insert when you create a record, right? And the R is for read, which is the select. The U is for update, and the D is for delete. So now we combine this together, okay? Where should a data scientist focus when it comes to these five different languages? What I would suggest you to do, right? You do not need to worry about DTL because it's going to be it's kind of hard for you to find a place as a data scientist where you will be able to create object on top of production, unless if you're working for a small companies, right? You don't need to worry me about granting access. That normally fall under administration team or security team. However, you as a data scientist should be able to master quad. You need to master the data query and manipulation language. And on top of that, you do need to have a good understanding of TCL. Why? Because not all the time the default behavior may work for you. There are some transactions you're doing, it might require you to take ownership of the execution times when it comes to commit. Great. So now you know where to focus, okay? Why should we think of SQL, right? We need SQL to perform analysis operation with the data that is stored in a relational database, like Microsoft SQL Server. A data scientist needs SQL to handle structured data, right? As the structured data is stored in a relational databases. So therefore, to query these databases, a data scientist must have a good knowledge of SQL syntax. By the way, there is, by the way, data is the most crucial part of the data science. You can't have data science without data. So creating, designing, and communicating with database object is essential for any data scientist to grow. Okay. So now you remember I was saying we first have to make sure the data is clean, right? What I mean, there's a tons of functions you as a data scientist should be aware of. The first one is what we call positions. Positions are some of the functions where you want to locate, especially if you're looking for a specific pattern within a string and you want to know how can you navigate between these patterns. This is where these functions are very valuable. The second one is the transformations. It's always great to find out what functions are available for you to perform some advanced transformations. And the third one is what we call character set, right? Character set, I will explain it a bit. And then the last one is sound decks. I will explain those two. If you think of positions, we can think of car index, path index, we can think of length. Those are the functions that will allow us to find the position of a string or a pattern or a string pattern. For the transformation, we can think of staff, string aggregate, we can think of substring, substring split, we can think of string escape, translate, and so on, like trim, replace, replicate. For character set, is that sometimes inside of your data, there might be line breaker, there might be tab. Those are the things you cannot use replace to clean that data. So therefore, for you uh, to replace this, you cannot use empty string. And you need to know when should you use ASCII and when should you use car to perform search data cleansing. Very important. For sound decks, sometimes if you're doing fuzzy searching, data cleansing, it's going to be hard for you to use and or like because the data have typo. You will need some functions that can look for similarity based on how your string is sound. For SoundDex, we can leverage this to do the first level of data validations. But for difference, if there is a manual data validations where inside of our pipeline anything doesn't match, we want to send an email to business and give them the required ID for them to validate if this is true from their end. Therefore, SoundEx may not be good. You might need to think of leverage, or you might need to think to leverage difference. Difference will take two SoundEx, compare them, and return a number from 0 to 4. 0, it's like it's going to be impossible to be true, right? 4, it's like it's hard not to be true. So therefore, there's a strong similarity that that string happen to be the correct string, right? For perhaps, for example, let's go to a demo, just to make it easy, uh, right? I have took some, I have take some screenshot and right, I'm gonna leverage it. It's going to be the same thing. Consider if I have this string, the goal is to know the locations of grid. If I need to know where grid is located, I can leverage car index. Car index give me an expression to find, an expression to search, and then the start location. This is optional. So my query would be like this, and I can see the positions is 11. Great. Things you need to understand. Car index is great if and only if you're looking for an exact word or string. If this string is vary, right, you cannot think car index. You're gonna think of what we call, for example, let me explain this. Consider if I wanna extract this one, okay? I want to extract grid out of this string, out of the entire string. I will need to use what we call substrings. I can add substring here, okay? And then this is the string that I pass here, and I need a starting point. That's the first comma, so I need a starting point, right? That starting point is that I can use car index to define it. It will start here, and then after that, guess what happened? This is just a very simple example, and I put 5 because grade have 5 characters. Great. Consider if now there is absolutely no exact pattern, right? The string can change. Car index will not help you. So therefore, you have to think of PATINDEX. How PATINDEX work? If you take a look, the goal is to find any string that contain big and end with driven.org. Here I have big data driven.org. Here I have big data.org. Okay. Here I have big data driven.org. You can see the length, the positions vary and index are not the same. So in this case, I cannot use car index. I will have to use PATINDEX. What I like about PATINDEX, it's allow you to use, for example, to search for, if you take a look here, this is for any match. If you want to search for a single character, you do have access. It gives you so much flexibility, and you can give your own sample if you want to, right? And then you can exclude some of the pattern here, right? How would we query this? I can use, this is just a table variable. that I'm using. I'm inserting that data. This is the same string you're seeing here, and I'm selecting. I'm using PATINDEX. What I'm doing here, I'm using substring, and I'm passing the expression. I'm using PATINDEX, and I'm giving the pattern that I want. It has to be big, driven, and that org. And then now I am looking for example. I need car index to position that org. So therefore, I know I will only need 4 character left. So if you take a look here, when I execute it, sorry about that. When I execute it, you can clearly see that only the big data driven return, but this one didn't return, as you can see. Great. Sometimes there might be, for example, um, requirements where business wants you to aggregate this. Consider you have this one and business want it that way, correct? So you can use aggregate functions to do that. As you can see here, I was able to do it this way, right? There might be, uh, consider if you have this one, you're doing some preps, okay? Business may say, this is good, I love it, but instead, I want you to bring me one line for each for number. Therefore, I can leverage string split to do that. And to do that, how would we do that? We can leverage string split to do it. So what I'm doing here, okay, this is the table, okay, and then I'm using string split, okay, and I'm cross apply and give it the delimiter. The delimiter is a comma, right? This is the comma, and I was able to split it. Just give me 1 second. Let me tell the kids to quiet a bit. Hold on, sorry about that.
You're muted, Gene. Okay, now you're not.
Yes, no, no, I asked, just give me a second. You know, the kids, yeah,
Sure.
and yeah, perfect. Yeah, so if you take a look here, I was able to do that. So now we're done with webs. Now we go into the analytical part, and I'm pretty sure this is where you will most likely focus. Things you need to understand when it comes to analytical part, you do need to understand the difference between aggregation, okay, aggregate functions and windowing functions. And also, when it comes to aggregation and analytical functions, you need to know when to use one versus others. If you take a look here for aggregate, we have a tons of them here, right? And for analytical, we have tons of them. We have first value, we have lag, we have lead, we have percent rank, right? For functions, for windowing functions, what I would like to remind you is that the default is range. If you don't explicitly mention rows, you might be doing some calculation, the subtotal match, but the details doesn't match because the range will follow, for example, your criteria and aggregate that, consider if it's on product ID, it will use that product ID wherever that product ID and business ID is the same, it will aggregate it. So therefore, if you analyze the subtotal, it match, but the details will not match. So I would highly suggest you to know, uh, I would highly suggest you to explicitly you mention either range or rows. If you want to do the analysis row by row, rows will give you better performance and better data integrity, because if the sub work, the detail will work, definitively work, because it will not aggregate your data based on range. Range is the default and it use TempDB. Therefore, not only you can get unexpected results set at the detail level, but performance may impact. You have to keep this in consideration. There will be also some other keyword you will need to understand: preceding, following, unbounded, and current. And also you have ranking functions as well that are available, dense rank and tab. So let's go and perform some analysis, right? Quick, before we do it, just a quick reminder, right? When we think of aggregate functions, you have to understand the entire data set, right? Will be grouped by whatever field or attribute you mention. Whereas windowing function doesn't group them. Instead, windowing function work at the row level and keep your entire data the way it is. It will only impact the column where you explicitly mention it, right? And if you take a look, there are multiple type of functions, right? Those are the same, but you can partition it, you can leverage other, these are optional, right? So let's go and perform some analysis. This is the demo time team. Consider marketing team reach out to you and say, provide total do, okay, total average sales order and total number of sales order and total sales rank. Orders for each year, including all fees, tax, and shipping. What we normally do, we will break it down into tasks. The first task we need to have is to get the entire sales order for each year. Then once we get that, that's when we're gonna start doing our calculations for the total due right here, total average of sales order by year, and we're gonna start calculating as well the total number of sales order by year. And then we need to know how well we perform. So therefore, there will be some ranking functions we will have to do. But things you need to understand, because the goal is to compare years, we will need to use group by. So therefore, you can see that this is our query. Okay. The first thing we need to do is to calculate the year. I have my year, my sum, which is the total sales by year. I have the average right here, and I have my count, and I have my rank. Okay. And I order by total due descendant, and I call it rank sales order by year. And I'm grouping by this function because I just need for the year, which is order date, and order by rank, right? When I execute this, oh, sorry about that. When I execute this, this is what I get. We can clearly see 2013 was the year we did well, and we were able to make tons of money. But for 2014, things wasn't good. Marketing team can leverage this information and find out what changed and what did we do for 20, for example, 13. And we can see in the result set as well, there might be some gaps. On 2011, we were good. 12, things get better, but 13 was the best. We dropped down to 14. They might need to, you know, perform some further analysis to understand what was changed to create that gap. Consider if they ask you to run total. Business may say, okay, provide the daily warning total due on sales order and include customer ID, sales order ID, sales uh, order date for the period of 2014 0601 onward, right? Um, and we need to order by sales, order ID, and order date. From such calculations, we can leverage what we call sum, which is a windowing functions. We leverage over order because we want the goal is wanting sales, so we definitively need to have that order and provide the sales order ID. Here, I explicitly say was unbounded precedent for me to get that warning total. And the criteria was from 2014, July 1st onward. So now I will have to mention this. And the order by was this criteria, and that's the two field that I have here. If I when I execute this, you can clearly see I was able to get the daily, the running total, right? We can clearly see this. If you add this to this, we have this. You add this to this, we have this. You add this to this, we have this. We were able to do the daily running total, as you can see, or the running total, if you will. Great. Let me consider, for example, marketing team again come back with you and ask you to return the first three orders plus the close price, the total order due, the total orders for every customer that purchase more than 15 times from us. So first, what we need to do here, because it's always great to understand the requirement. So we need to find all order details per customer. We need to return only the first three orders per customer with the close price, the total order, where the total order count is greater than 15. So now things get a little bit complicated. What we can do, we can create a CTE. If you take a look, this is the field they want me to return, and I need that count because I just need to return the first three orders. So therefore, I need to have a count on sales order ID, and I have to partition it by customer ID because they do not want us to return the entire record. They just want us to return the first three records for each customer because they need to know which customer purchased more than us, spend more money in us, which customer I need to find out uh, one of the greatest customers. So for me to do that, I need to know the first three product they purchased and how much they were. For, for example, if you take a look here, this is the one number. I'm using partition here, right? And by customer ID and order by sales. And I need to return only the first three orders. The reason why I have this inside of the CTE was when you're using windowing functions, you don't have access at the data to filter because once you execute that query, the calculation will be done at the row level. So therefore, I will need to have a subquery or a CTE for me to uh, encapsulate the result set. And then here, and I'm calling this CTA and then return this, and the total uh, orders has to be greater than 15. If they purchase more than 15 times from us, those are the customer I need to know. If it's or equal than 15, I don't care. So when I execute this, I was able to get that result set. As you can see, You can clearly see for each customer, I was able to return only the first three purchase they have done from us. Great. Consider now if they say the marketing team say, yeah, I'm happy you provide me that data. Now I'm gonna give them a good discount for them to come back because the goal is to compete against 2013. I need to know why we were not able to do good the way we used to. Marketing team may come say, listen, I need that same result set. However, I want it to be 10,000 more in purchase. Those are the customer that I need the first three transactions. Give me the first, give me customer that purchase the first three times that were able to spend more than $10,000 from us. So if you take a look here, we can find the first three customer, the first three orders per customer, correct? We can aggregate the first three orders. We can return all the orders for those customers because they want us to return the entire thing this time. And then we can, so now we will need to return all customer where the money happened to be greater than 10,000. So now, guess what? The first city, what it's doing, it's calculating the first three order, the sales by order. That's the first one, right? The second one, because now I have the number of sales, what I need to filter out, right? The first three, and I need to perform my calculations, right? So now out of this result set, I can get the first three. And then here I'm doing that calculations inside of that CTE, and I can mention, okay, I need, for example, the first, I need where one number is equal to one, okay, to one, and also the total due has to be greater than 10,000. When I execute this, you can clearly see, if you take a look here, if you add these three, you will see this three is greater than 10,000. If you add these three, you will see that these three, the total of these three is what you get here. And this customer purchase more than three times, but we want to aggregate, we want to know, give us a details for any customer that bought, for example, three items that happen to be more than 10,000. Not only you have the entire transaction details, but you were able to give the summations of the first three orders. And then if it's greater than 10,000, the data return. And if you add these three, you will see it is definitively greater than 10,000. Sometimes there might be cases where, for example, they want you to calculate the first and the last close price, or right, for each day of every month of the year, including every single details. If we want to perform such calculation, we can use what we call first value and last value to calculate first and last close price. And because they want it to be for every month of the year, we will have to partition this and use month functions out of that due date. And then we want it as well to be by year of order date. And these order date come from purchase order ID, and the other one come from, if I'm not mistaken, purchase order header. So therefore, for example, here I am ordering by POH order date. And this is happened to be the first close price and the last close price. When execute this, that's what we get. The first close price was 201.04, and the last close price was, for example, this is the last one. Okay, that's the first one and the last one. The last one was 171 and 0.7 cents. Great. There might be cases where you will have to reshape that data, and reshaping that data might require you to do some extra work. And then what I was doing for an advanced um, demo to when it comes to reshaping, pivoting, or transpositions, I found a website, a great article, and I forgot to save the URL, and I want to give credit to whoever did it. This didn't come from me. I modified the query a bit to match my expectations. Okay. And this, even you will like this demo. Consider, for example, you have this data, and business wants you to calculate the total due for each month and get the subtotal for each year by region and territory. So now this is where you can think, for example, of ha having you draw a document or document what needs to be done, because such operation might require you to think twice, right? So what I'm doing here is that if you take a look, the goal is to break it down by month, subtotal, and by year for each territory region. If you take a look here, the month is January. We have for Australia, Canada, okay? And then we have a month total here. How cool is this, right? Great. That's how we want it. And to do such operations, you will need to create kind of uh, things, kind of advanced, not really advanced, but you do need to understand SQL a little bit. You do need to have good experience in SQL. Otherwise, you might prefer to do it in Python or Scala as a data scientist, right? So what we're doing here, I am defining an identity for me to be able to navigate to the data, okay? And then here I'm inserting it. So I'm using date part grouping, okay? And then if you take a look here, there's a roll up I'm doing here. So now with this result set that coming from my select query, I'm using this table here, and I want where is grouping rows is equal to 0, and I'm grouping by month. If it, that's how I was able to get the subtotal for each country. So now I need the subtotal by month for each country, and I need a complete total for the entire month for each country. I will have to union all, okay, and perform a total calculations, as you can see, and then bring that. That's how I was able to get this result set. If you take a look here now, the data happen to have a different shape. Take a look. So now I have the month here, I have the country here, and I have my month total. Okay, for this month, for the entire country, this is how much sales we made, and then this is the grand total for each country. It look, it might look complicated, but once I share this with you, this slide with you, and then you take a look at it, you will see how great is this demo. It sounds a bit advanced, but this is something kind of in our daily task. That's what we normally do. Great. What would be the 5 things that I would highly suggest you to know is that as a data scientist, I would suggest you to have a deep understanding of quad and you have to master it. And because of you do need to understand acid, right? I, and you do need to understand your TCL, which is transact control language, right? And then sometimes you might need to not quietly that will fall under your responsibility, but you need to understand the query optimizer because you will be creating or writing script. Understanding the behavior of the script might make sense to see if you need to use index or not. Understanding index will speed your reading, but it will slow down your load process. So therefore, any update, delete, insert happening will slow down. And then when you creating your process, it's always good to come up with what we call an exception mechanisms. If anything fail during the executions, at least you log it somewhere, and that will allow you to save time when it comes to troubleshooting. Yeah, key way is to have a deep understanding of ACID, mastering what we call data query language and data manipulation, and then know exactly when to leverage TCL. If you have any questions, feel free to ask. And don't forget, your feedback is very important. This is the end of the presentations. I would love to know if you have any question. If you do, I'll be happy to debate with you. And if I can, I will find out and reach out to you. Update Steve, and therefore Steve can follow up with you. By the way, thank you so much, Steve, for hosting this user group and giving me a chance to share my knowledge and experience with your community.
Thank you for your presentation. This session is recorded and will be published to YouTube and Rumble once it's all published. Thank you everyone for joining our online meeting today. With that, thank you, have a great day, and see you here in your next meeting.
Thank you so much one more time to all attendees and to the organizers. Yeah, and hopefully next year I'll be able to present again. Enjoy the rest of your day.
You too. Thank
Bye
you.
bye.
Bye-bye.
Bye.
Thank you. Bye bye.